What's up, you freaking geniuses? So in this video, I'm going to teach you how to graph rational functions that have slant asymptotes. All right, so I'm going to teach you how to find the intercepts, the asymptotes, and the domain and range. So the example that we're going to cover right here is f of x is equal to x squared minus x minus 2 all over x minus 1. All right, so the first thing we want to do is find the intercepts. Specifically, let's start with the x-intercept. And in order to find x-intercepts, you simply have to set the numerator equal to 0 and solve for x, all right? So the numerator that we have here is x squared minus x minus 2, and we're gonna set that equal to 0. Now normally you'll be able to factor these trinomials, and in this case we can. So here we can break this up into two sets of parentheses, and again it's gonna be equal to 0. And x squared, we can break that up into x times x. And then here we need two numbers that multiply to -2, but add up to -1. So in this case, that would be a -2 and a +1. All right, so now that we factored this, we simply have to set each of our parentheses, each of our factors, equal to 0. So first of all, we're gonna have x minus 2 is equal to 0, and we'll also have x plus 1 is equal to 0. So on this side, solving for x, we're gonna get that x is equal to +2, and on this side, we're gonna get that x is equal to -1. All right, so these are our two x-intercepts. So at -1 and +2. So let's graph those here on this bad boy. So here's our x-axis. We're gonna say -1 is right here, and +2 is right there. All right, nice. Now let's find the y-intercepts. And in order to do that, you simply have to plug in a 0 for all of your x terms and then see what pops out for f of x, or in other words, y. All right, so then here, to find again the y-intercepts, we're gonna plug in a 0 for all inside of all these x terms. So we're gonna get 0 squared minus 0 minus 2 all over 0 minus 1, all right? 0 squared is 0, and 0 minus 0 is 0, right? So then 0 minus 2 is equal to -2, and here we get -1. So -2 divided by -1 is equal to +2. So we have simply one y-intercept right here, right, at +2. So let's graph this guy now. So here's our y-axis. +2 is right there. Okay, great. So now the last things that we have to do are simply graph the horizontal or slant asymptote and the vertical asymptote. So first of all, in order to figure out what kind of horizontal or slant asymptote you're gonna have, all you have to do is look at the biggest exponent on the top and the biggest exponent on the bottom. Here, there's no exponent, right? So we can assume that there's a 1 right there. So on top, the biggest exponent again is a 2, and the biggest one on the bottom is a 1. So here you can see that the top exponent is bigger than the bottom exponent. Okay, now there's three different cases that you might run across. If the top exponent is smaller than the bottom one, you're gonna have a single horizontal asymptote at y is equal to 0. If these two exponents are equal to each other, then you'd have a single horizontal asymptote at the ratio of the leading coefficients. But if the top exponent is bigger than the bottom exponent, like we have in this case, then that means we're gonna have a slant asymptote. So now that we know we're gonna have a slant asymptote, how do we actually find it? Well, in order to do that, you simply have to divide this basically fraction. And you can do that two different ways. You can either use synthetic division or polynomial division, or I guess a little more specifically, polynomial long division. Now, if you're not sure how to perform either one of those, I'll drop a link to both of those in the description below. But here I'm going to use synthetic division, and I'll briefly go over how to actually do it, all right? So here, again, we want to divide x squared minus x minus 2 by x minus 1. So the first thing that you want to do is take your denominator and solve for x, all right? So here, we're going to take our denominator, x minus 1, we're going to set it equal to 0, and then we're going to solve for x. So here to solve for x, pretty easy, right? We can just get rid of this -1 by adding 1 to both sides. So here we get that x is equal to +1. All right, so now I'm going to draw this big kind of upside down division looking symbol. And what we got right here for x, we're going to write it out here. So we're going to put a 1 right there. The next thing we're going to do is write some numbers right here, and specifically they're going to be coefficients. All right, where are we getting these coefficients from? The numerator. All right, so what are the coefficients up here? Well, here there's a +1, here this is a -1, and then we have this -2. All right, so those are our three coefficients right here. So we're going to have a 1, a -1, and -2. Okay, so our very first coefficient right here to the left. All we're going to do is bring that straight down and write it out here, okay? Now the next thing we're going to do is take the number that we had out here and multiply it by this number. So 1 times 1 is equal to 1. Where are we going to put that number? Right here underneath the next number, all right? Now we're going to just start adding these numbers together. So -1 plus 1 is equal to 0. So we're going to get a 0 right there. Okay, now 1 times 0 is equal to 0. So again, that'll go in the next column right here, and then we'll add those two up. So -2 plus 0 is equal to simply -2. Okay, now the way that we come up with an equation for the slant asymptote is by using these numbers that we got down here. So this very last number, it always represents your remainder, okay? Now the next number over is going to represent your x to the 0 power. And then the next number is going to represent your x to the first power term. And if we had more numbers over here, those would just represent your x squared terms, your x cubed terms, and so on, all right? I think you kind of get the gist. So to write the equation, we're simply going to say that y is equal to, and then we're simply going to multiply these numbers together. So 1 times x to the first power is simply equal to 1 times x to the first power. Okay, then we're going to add the next number, so we'll say plus. This next number is 0, and then we have an x raised to the 0 power, right? So x raised to the 0 power. And then our remainder, we're actually not going to care about it. Okay, simply because we don't need it for the linear equation, right? So then here we're going to get that y is equal to, now x raised to the first power is just equal to x, right? So here we really have just one x, or in other words, we can write that as simply x, right? So let's write an x right there. And then here we have x raised to the 0 power. Now remember, anything raised to the 0 power is equal, let's just write it over here, it's equal to 1. All right, so here we really have 0 times 1. And 0 times 1 is equal to 0. So then here we have plus 0. So x plus 0, that's the same thing as just x. So we can simply leave this as y is equal to x. All right, this is the equation of our slant asymptote. Okay, so this is just going to be a straight line. And in order to graph a straight line, you only need 2 points. Okay, so let's make a little XY table right here and graph 2 points. So let's plug in some numbers for x, and let's just keep it easy. Let's just say 0 and, I don't know, 5. Okay, so if we plug in a 0 into the equation right here, a 0 is also going to pop out, right? So this first coordinate point we're going to have is 0, 0. And then if we plug in a 5 right there, well, a 5 is going to pop out, right? So then we'll also have this other coordinate point, 5, 5. So let's graph those 2 points. And let's use a different color this time. So let's use purple. So again, 0, 0, that's just the origin. And then 5, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, there's our 2 points. And then we'll just draw a straight line through those 2 points. All right, now the last thing that we have to do is find our vertical asymptotes. And in order to do that, we simply have to set the denominator equal to 0. So our denominator in this case is x minus 1. So we'll set that equal to 0. So here we can see that x must be equal to +1. All right, so on the x-axis, right, +1 is right here. And we'll label it at x is equal to 1. All right, so now that we've found all of our intercepts and asymptotes, now we can finally graph this guy. So as you can see, we have a couple intercepts already on this side of the 2 asymptotes. So we know that the graph of the function is going to get really close to the asymptotes, right? And then it's going to run through those intercepts that we found. And then again, it's going to get really close to this asymptote right there, okay? So this side is going to look something like that. And then we have another asymptote, or sorry, another intercept that we found right here at this point. So we know it's going to kind of mirror this function. So that means this function, again, it's going to get really close to this asymptote. It's going to run through that point, and then get really close to the asymptote one more time. Okay, so that's what our graph would look like. Now the last thing that we want to do is just find the domain and range. So let's write those over here, the domain and the range. So remember, the domain is basically like your side to side, your x limits, and the range is your vertical up and down, your y limits. So first of all, let's start with the domain. So the domain, we're always coming over here from negative infinity, right? And we're going towards this side, right? Towards positive infinity. So here, as you can see, as we're moving along the x-axis, we have a function, right? We have a valid function as we move along the x-axis. We're good, we're good, we're good. We have function. But then here at this vertical asymptote, that's where the function stops. And then it basically skips over the vertical asymptote and then picks back up right here. So the domain in this case would be from negative infinity, right? That's where we're coming from. And then we're going to hit positive 1, and then we're going to jump over 1. So we're going to put a union symbol, and then we're going to pick up right after 1, and then we're going to head off towards positive infinity. All right. Now for the range, we're coming down here from negative infinity, right? And then heading up here towards positive infinity. So here, as you can see, we have valid function, we have a valid function, we have a valid function. Both of these functions actually have the same range, and there's no break in those functions, right? So then the range here would simply be from negative infinity to positive infinity. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.